Hello, everyone. Welcome to the Mathematician's Den. What we are going to do here is we are going to look at how to find the slopes of tangent lines, first of all, at any point on a curve. Secondly, how to find the exact slope at a point on the curve, and then write the tangent line. And I've got three different examples to show you here today, and then we're going to look at the graphs too. And the difference quotient I'm going to use is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And what I'm going to try and do here as well is I'm going to try and color code everything I'm doing. In other words, what does it mean when I ask you guys for f of x plus delta x? Well, I have to plug x plus delta x into this function wherever I see an x. So I've got x plus delta x cubed minus 3 times x plus delta x. Now, I think everybody knows what it means if I say f of x. I have to subtract the entire function x cubed minus 3x. And then this whole thing is all over delta x. Now, in order to figure out this limit, I'm going to have to expand this whole thing. Now, if you don't know how to expand something to the third power, here's how easy it can be. Start with the x, write x cubed, write x squared, x to the first, and then x to the 0 would just be 1. Now do the same thing backwards with the delta x's. Delta x cubed, delta x squared, delta x to the first, and then no delta x on the first term. And here's the kicker. Pascal's triangle. Pascal's triangle looks like this. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. How did I get the threes? I just add the two numbers above it. Add the two numbers above it. It always starts with 1. You'll notice the next one should be a 4 because 1 plus 3 is 4. 6, 4, 1. This is the third row of Pascal's triangle. We're going to use 1 plus 3 plus 3 plus 1. Then on the next part, I got to distribute the 3. So minus 3x minus 3 delta x. And then from the green, I also have to distribute a negative, get minus x cubed minus 3x. And this whole thing would be all over delta x. Now let's take a look what's going to cancel in this thing. X cubed minus x cubed, gone. Okay? And sorry, I forgot, this should be a plus 3x because I got to distribute my negative. The negative 3x and the positive 3x are going to cancel too. Now I've got a ton of terms left here, and we're going to simplify them right now. What is this term divided by delta x? It'd be 3x squared. This term divided by delta x would be plus 3x delta x. This term divided by delta x would be delta x squared. And this last term over here divided by delta x would be minus 3. Now remember, delta x is going to 0, so those middle two terms are both going to go to 0. And so I get 3x squared minus 3. Now what this formula represents for this original function, this represents the slope of the tangent line at any point on the curve. What do we call this? This is a derivative. And the notation looks like this. For derivatives for f of x, f prime of x. This is the first derivative of my function. Now, why is this important to me? If I give you an x value now, let's say x equals 2. I want you to write the equation of the tangent line. Now, what do I need for the equation of the tangent line? I need the y value, and I need a slope. The y value, just plug in 2. I would get 2 cubed minus 3 times 2. That would come out to be 2 as well. Now, to find the slope, what you use is the derivative. The derivative is the slope of the tangent line. You would take 3 times 2 squared minus 3. And that comes out to be 12 minus 3, which is 9. So when we take a look at this graph, the tangent line is going to be this. And the tangent line form that I like to use is point slope. Right here, we have a point, we have a slope. So y minus y sub 1 equals m times x minus x sub 1. This would be y minus 2 equals my slope, which is 9, times x minus 2. That is the equation for my tangent line. Now, when I go to actually type in, sorry about my computer noise, to type this in, I've already graphed this function. Now, we said this tangent line was going to be y minus 2 equals 9 times x minus 2. Now, if you take a close look here, at the coordinate 2, 2, and let's put that on there as well. Let's put the coordinate 2, 2. That definitely looks like a tangent line at the coordinate 2, 2, doesn't it? So we found the correct formula for the slope of the tangent line. We found the correct derivative. We found the correct tangent line to this curve. Now you notice that was pretty easy because that's a polynomial. And let's face facts, polynomials are always the easier ones. What do we do if we have a radical? If you've watched any of my other videos, you know when we deal with radicals, we may have to deal with some rationalization. So we're going to do again the limit as x, delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now again, let's use some color here. What is f of x plus delta x? Well, I'm going to plug it into here. It'd be radical. Instead of x, it's going to be x plus delta x, and then, of course, there's the minus 3. And then I have to subtract delta x, or sorry, subtract f of x, which is radical x minus 3, and then this is all over delta x. Now, what I haven't mentioned so far, and I should have, if you plug in 0, you're going to get 0 on the bottom, you're going to get 0 on the top, so this is an indeterminate form. And how do we solve indeterminate forms? We do things another way. We solve the limit another way. We're going to multiply by the conjugate, x plus delta x minus 3 plus radical x minus 3, and we're going to multiply by that on the top and the bottom. Now this is going to get ugly. That's okay. The bottom, I am not going to multiply out the bottom. It's going to be delta x times that conjugate, x plus delta x minus 3. Then it's going to be plus radical x minus 3. And on the top, what you're going to get, multiply the first terms, you get x plus delta x minus 3. And then you have to subtract the result of multiplying these two, which is x minus 3. The top, just to save some time here, you know this is minus 3. This is going to be plus 3. Those are going to cancel. This is x. This would be minus x. So those are going to cancel. Now notice there is a delta x left on the top right now, and there is a delta x on the bottom. If you cancel those, that's the 0 over 0. So the only thing left on the top is 1. And on the bottom, delta x here approaches 0, so I get radical x minus 3 plus radical x minus 3. My final result is 1 over 2, radical x minus 3. And ladies and gentlemen, that is my first derivative of this function. So let's pick a coordinate. Let's just pick an x value. Let's say x equals 7. If I plug that in to my original function, I'm going to get the square root of 7 minus 3, which is 4. The square root of 4 is 2. Well, how do I find the slope? The slope, what you do is you put 1 over 2 radical 7 minus 3. You use the derivative. So this would end up being 1/4. So my tangent line would be y minus the y value equals my slope times x minus the x value. Now again, what I'm going to do here is I'm going to show you what this graph looks like, and I'm going to show you that we actually found the correct derivative. So I'm going to turn these first two off. And what I'm going to do is I'm going to put in y minus the y value, which ended up being 2, equals 1/4 And then in the parentheses, I'm going to put x minus 7. Okay? If I turn on that function, and again, I'm going to put in the coordinate. I'm going to put in the coordinate as 7, comma 2. Now, if you guys take a look at this graph, tell me that doesn't look like a tangent line at 7, comma 2. This is something you need to be able to do for calculus classes. You've got to be able to find, number one, the derivative, the formula for the slope of a tangent line at any point. Then you've got to be able to find the slope at any point and write the tangent line. We're going to do one more graph here today, and it's 3 over x. Okay? 3 over x, what we're going to do is I'm going to use a different formula this time. I'm going to use the limit as h approaches 0, f of x plus h minus f of x all over h. And this time, just to save some time, I'm not going to use a whole lot of color. F of x plus h would be 3 over x plus h, minus f of x would be 3 over x, and on the bottom I'd have h. Now, thinking common denominators, with a complex fraction like this, I got to multiply by x here and here. I've got to multiply by x plus h here and here. And what happens is I get a new limit, a new formula. It would be 3x, and over here, if I distribute, I'd get minus 3x minus 3h, and the common denominator on the bottom would be x times x plus h. That's the top. Now, where does this h go? Well, you'd take the bottom and multiply it by the reciprocal by the top. That would put the h on the bottom here. Now look at everything that's going to cancel here. Let me get some nice bright green here. The 3x's are going to cancel. It leaves me with this term on the top, and take a look, there's an h on the bottom. I can cancel those h's now. The top is negative 3. The bottom, and since h approaches 0, I'd get x times x. Ladies and gentlemen, the derivative is negative 3 over x squared. This is my derivative. And we're going to pick a simple number to plug in. We're going to pick x equals 1. So the y value would be 3 over 1, which would be 3. And here we're going to use the derivative to find the slope. It'd be negative 3 over 1 squared. The derivative is negative 3. So my tangent line would be y minus 3 equals the slope, which I found from the derivative is negative 3, times x minus 1. That, ladies and gentlemen, is the equation of my tangent line at this particular point. So if I go back to Desmos and I look at this graph, and I'm going to type in fact, I'm going to do the coordinate first here. If I plug in 1, 3, there's the coordinate I was talking about. And here's the thing. If I type in the tangent line y minus 3 equals found my slope to be negative 3, and that's going to be multiplied by x minus 1, well, what do you know? That's a tangent line. If you like this video and it helps you, please hit the like button. And if all my videos are helping you, I would appreciate it if you hit subscribe, because I'll be putting up more videos in the future here.